Afternoon, sir.
Hey, Shamari, how you doing?
Pretty good, sir. Hope you're doing well too.
Giving thanks. Giving thanks. Were you able to finish this question that we started towards the end of the class last Monday?
Yes, sir.
Right, good. 2/9 minus 2/3. What did you get for the critical points?
Oh, I think I got this part wrong. The 1 and -1, and I got -1/3 and 157/27.
157. Is it 157 supposed to get? It's not 157 supposed to get. Supposed to get 145/27. Look at that one again for me.
All right, sir.
All right, this is 521, and I don't see anybody else. Did you fix it, Shamari?
Yes, sir. I see where I went wrong.
What you got now?
The 145 over 27.
Good job. Did you calculate the y-intercept?
Yes, sir. 0.5.
Good job. What's the nature of the critical point?
Eight and -8.
Yeah, but we can't tell me that, the -8 is what and the 8 is what.
8 is minimum, the -8 is maximum.
Very good. It's a point of inflection.
1/3 and 113 over 27.
Check to see if 113 over 27 is the same thing as 4 and 5 over 27 for me.
Yes, sir. I had worked it out when I saw that you had it as a mixed number.
Okay, good. And then now, that's my sketch. So you can see where my maximum is. It's only a sketch, but you see, notice, what I did, I write out all the points. My minimum point, 1, -3, you can see that on the graph. My maximum point, -1/3 and 5 and 10 over 27, you can see that on the graph. What I did there was to work out what that fraction is, so I can approximate it. So 5 and 10 over 27 is approximately equal to, and that's what that sign means. It's approximately equal to 5.3. So what I did, when I went to -1/3, I went just a little bit above 5. It's a sketch, so it has to be plausible. So anybody put it at 5 will lose a mark. But if you put it just a little bit above 5, you should be good to go. The 0.5 is right here. The 1/3, positive 1/3 is here. And 4 and 5 over 27 about 4.2. So this went up to about 4.2 thereabout. That's it. All right, so you had sent a question in the group, Shamari, or was it just me I sent it to?
Just you I sent it to, sir.
Can you drop it in the group now for me, please? So that the pair of you can go ahead and do it. Did you do it already?
No, sir, I haven't done it as yet.
All right, so go ahead and let us just use a few minutes on this to that. If the others don't come back, I'm gonna finish it. We're gonna move on. Please, I'm gonna overemphasize my request again. This topic is a must-have on the exam paper. It is a must-have on the exam paper. There's no calculus paper that can come without this question on it. Matter of fact, this topic is again going to come on calculus 2. Just like for calculus 1, you're looking at single variable options or single variable functions. And in calculus 2, we're going to be looking at multi-variable functions. But again, we're going to be looking at stationary points. So, I were you, I pay special attention on this topic. It's a must-have. Matter of fact, I'm hoping it's going to be a full topic. All right, thanks, Ramari. I'm going to give you 10 minutes to work through all the parts of that question. Remember, we're gonna determine the critical points. We're gonna determine the critical points. We're going to look at the y-intercept. Then we look at the nature. We can calculate the point of inflection. We can sketch a graph. Every single time. 10 minutes starting now, please. Anybody get the critical points yet?
Yes, sir.
Okay. All right, so let me just work through this first one so that for those of you who are struggling, you can see what is happening. So I differentiated the function 3x squared minus 6x minus 9 equals 0. I recognize that 3 is common. 3 is common to each of the coefficients. So I'm dividing by 3. So I'm dividing by 3. So therefore I get x squared minus 2x minus 3. I'm going to factorize that. I'm going to need my factors are going to be 3 and negative 1. Agreed? No, negative 1 and positive. Negative 3 and positive 1. Agreed?
Agreed,
Yes, sir,
sir.
agree.
So I'm going to have now x squared minus 3x plus x minus 3 equals 0. Then I'm going to group to give me x squared minus 3x in one bracket. Leave out the middle sign every time. Then I have x minus 3 is equal to 0. What is coming between x squared and x is going to be x. Then I'm going to have x minus 3 that is left. Leave out the plus sign. What is coming between x and negative 3 is going to be 1. So we have x minus 3 equals 0. And then x minus 3 times x plus 1 is equal to 0. So either x minus 3 is equal to 0, which implies x is equal to 3, and x plus 1 equals 0 implies x is equal to negative 1. Tell me if you agree or disagree. Agree or
I
disagree,
agree,
please?
sir.
Agree, sir.
All right, good job. And then now, those are my critical values. Oh, crap. Oh my Lord. I pray for favor. I pray for favor. Okay. This thing gives me problems every time. Okay. So I'm going to put x equals 3 into y equal x cubed minus 3x squared minus 9x plus 2. So y is going to be equals to 3 cubes minus 3 times 3 squares minus 9 times 3 plus 2. Y is equals to 27 minus 27 minus 27 plus 2. How are we going to write this? That cancels that. Y is equal to negative. You get negative 25?
Yes, sir.
So my critical point here is going to be 3 comma negative 25. Similarly, I'm going to put x equal -1 into y equals x cubed minus 3x squared minus 9x plus 2. So y is going to be equals to -1 cubed minus 3 times -1 squared minus 9 times -1 plus 2. Y is equals to -1 cubed is -1. -1 squared is +1. +1 times -3 is -3. -9 times -1 is going to be +9. And plus 2. 3 and 1 is 4. -4 plus 5 plus 9 is 5. 5 plus 2 is equal to 7. You get 7?
Yes,
So
sir.
my critical point is going to be -1, comma 7. No, that looks like a 9. All right. What do I do next now? If I'm doing the nature of the critical points, okay, let's just do the y-intercept first. When I've calculated the y-intercept, what do I do?
You're going to put x equal, you're going to substitute 0 for x in the
Very,
original function.
very good. So therefore, x equals 0. So y is going to be equals to 0 cubed minus 3 times 0 squared minus 9 times 0 plus 2. Y is equals to 2. So my coordinate is going to be 0, 2. Agreed?
Yes,
Yes, no?
sir.
Good job.
Agreed.
Nature of the critical points. Nature of the critical points. dy by dx is equals to what's dy by dx? Okay. X squared minus 2x minus 3. X squared minus 2x minus 3. So therefore d squared y by dx squared is going to be equals to 2x minus 2. Right?
Oh, sir, where I get that from, sir?
Or what you use? What you use? You use a 3x squared minus 6x minus 9.
Yes, sir.
All right, let me use it. It doesn't change it, but for consistency, let me use it. 3x squared. Repeat it for me, please. 3x squared minus 6x
Minus 9.
minus 9.
So what are they used before? Could you
Huh?
just show what are they used before? And you said it could have been used.
What I did was to use this one, don't you? Remember, I had divided 2 by 3. So
Oh, okay.
let me do 2 ways and show you. So 3 2's are going to be 6x minus 6. All right. And if I had used dy by dx as x squared minus 6x minus 3, d squared y by dx squared will be equals to, no, that would be 2.
And this, yeah.
That would be 2x minus 2. So for my critical point, 3 comma negative 25. For critical point, 3 comma negative 25. D squared y by dx squared is going to be equals to 6 times 3 minus 6. 6 3s are 18 minus 6 is going to give you 12, which is positive. So we're going to have a relative. Agreed?
Agreed.
So watch this other method now. If I use d squared y by dx squared, which is equals to 2 times 3 minus 6, sure, minus 2, it's going to be equals to 236. 6 minus 2 is going to be equals to 4. Still positive, don't?
Yes, sir.
Relative minimum. And then for critical point, what was the other one? Negative 1 comma 7. Negative 1 comma 7, guys. If you know this, you get whole heap of marks already on the exam. It's going to be 6x minus 6. It's going to be 6 times negative 1. Whoa. Minus 6 is going to equal to negative 12. Talk truth. So it's going to be relative maximum. And if I'd done it the other way, where d squared y by dx squared is equals to 2x minus 2, I would have gotten am I correct? What am I doing here? Why did I have, hold on, 2x minus 2? Yeah, I'm correct. It will be 2 times negative 1 minus 2, which is going to be equal to negative 4. See that? I still get the relative maximum. Indeed?
All right, sir.
So if you want to be consistent, you can just go ahead and just use the original derivative, if you feel much comfortable with that. And I would say use the original one as a just in case, say you make a mistake and when you do the division, it may throw you off. So just be consistent and use the original one. You follow what I'm saying? Anybody, somebody?
Yes, sir.
Yeah, man. So just use the original dy by dx in the event, just in case you made an error with the second with dividing through the dy by dx to reduce it. You made an error. That error won't be carried forward into the other part of the question. Am I clear?
Yes, sir.
Okay. So that's the nature of the critical point. Then I'm gonna ask now to calculate. Oh crap, I finished it already. Say for example, the afternoon to calculate the point of inflection. Recall d squared y by dx squared is equal to 6x minus 6. I'll say, oh, and when I set this equals to 0, so 6x is equal to 6. Divide both sides by 6. It implies that x is equals to 1. Yes, no, maybe so?
Correct.
Good job. So I'm going to put x equals 1 into my original function y, which is equals to x cubed minus 3x squared x cubed minus 3x squared minus 9x plus 2. Tell me if I got the function right, please.
Yes, sir, it's correct.
All right, good. Thank you, sir. So I'm going to have no y is equals to 1 cubed minus 3 times 1 square minus 9 times 1 plus 2. It's going to be equals to 1. 1 squared is 1. 1 times negative 3 is negative 3. Negative 9 times 1 is negative 9. Plus 2. Wow. Negative 3 plus 9. Negative 3 plus negative 9 is negative 12. Negative 12 plus 2 is negative 10. Negative 10 plus 1 is negative 9. That you get?
Yes, sir.
So the coordinate of the point of inflection is going to be equal to 1 comma negative 9. Is there anything else that you could ask us to calculate? We've calculated everything, don't?
Yes, sir.
Only thing that is left for us to do now is to sketch it. All right, so my points that I'm interested in are going to be, starting from the top of the question, go back to the pages where though. The points that I'm going to be interested in is going to be my critical points, 3, negative 25 and negative 1,7. 3, negative 25 and negative 1,7. And the 3, negative 25 is a minimum, and the 1, negative 7 is a maximum. I know that. I pretty like that because the minimum can turn up and the maximum is going to turn down. The other point I want now is the coordinate of the oh, 0,2. My y-intercept is 0,2. And then now, 1, negative 9 is my point of inflection. See, all these 3 points, 4 points must be on my graph. So my largest x value is going to be 3. So I can call this 1, I can call that 2, I call that 3. My largest y value is negative 7. Sure. Negative 25. Where do I go with that? So it's a sketch. All right, let's call this negative 1, negative 2, negative 3. If I call this up here, so 5, that means here says 10, here says 15, here says 20, and that's 25. So every other one is 5, bam, 10, bam, 15, bam, 20, bam, 25. Bam, negative 5, negative 10, negative 15, negative 20, negative 25. Do you agree with that?
I agree.
Was that a yes or no?
Yes, sir.
Mhm. Simon,
Sir.
you agree?
Yes, sir.
Shamari, how is it?
I agree, sir.
Mhm. So we have to the calibration of our sketch. The top half of the y-axis must be the same as the bottom half of the y-axis. And the left of the x-axis must be the same as the right of the x-axis. All of them don't have to be the same. So I can have a different calibration for the y-axis than I have for the x-axis. But what is up the top of the y-axis has to be the same calibration at the bottom of the y-axis. And what is to the left of the x-axis has to be the same to the right of the x-axis. All right, have to be the same. So let's go. I'm putting on my points now. I'm on a different color to show that. 0, -2. 0, boy. If this is 5, that means if that is 5, I'm going to call this 1, 2, 3, 4, 5. So 0, -0, 2, 0, 1, 0, 2 come right about here. So agreed? All right. And then no 1, -9. So this is -5, -6, -7, -8, -9. So -9 is right here. So and 1 is right here. So tell me agree with me. And I'm doing this so that if you don't see it, you can let me know that you're not seeing it. So let me know if you're seeing it.
Seeing it, sir.
Good job. And then now we have -1, 7. This is -1, 7R. So this is 5, 6, 7, 8, 9, 10. So this is 5, this is 7. And then 3,25 is going to be all of this. So what is happening now? 3,25 is the minimum. So it turns up. So this better turn up so. And the -1,7 is the maximum, so it turns down. This better turn down so. And then the y-intercept is 0, 0, 2. So it must cut this. It must cut it right here. So it will come down. Okay, my hand is shaky. So in essence, that's what the graph looks like. It must pass through that one. And it's going to come through here. Do you see? Do you agree?
Yes, sir. I agree.
All right. So let me do something. It's, oh gosh. Give me the function again. No? It is x cubed
Minus 3x squared minus 9x plus 2.
Talk about it.
X cubed minus 3x squared minus 9x plus 2.
Right. So x cubed minus 3x cubed minus 9x plus 2. All right, so let us look at the, let me hide this. Oh, you see the 3 comma negative 25 right there, so? And the negative 1,7 right there, so? And the 0,2 right there, so? We did not calculate these, but we saw where this was coming to be negative 2,0. So how did you see that? See it almost like it right here, so can you see this? Hello? Mm-hmm. So that's what it looks like. So the basic shape of the graph, we would have gotten the basic shape of the graph. So would have gotten that basic shape of the graph. So we would have gotten the full marks for the question. So, you know, it's so what I did. I wrote down all the points that I know must go on the graph paper. Because if you get points for putting the graph, the marks for putting the points on the paper. And you also get marks for connecting the points in a smooth curve. And that's what the sketch is. Title your sketch. You get marks for that.
The title, the function.
Yeah. So sketch of y is equals to x cubed minus 3x squared, I think, minus 9x plus 2. And you underline it. Full marks. You go into the exam and you do something like that. Full marks. I'm going to pause right here for 1 second. All right. Students, I cannot overemphasize the importance of this topic. Hear me. It is better you prepare for this topic and you go into the exam and there's no question on it and you move on, then you don't prepare yourself and you go into the exam and there's a question looking and smiling at you. And you see the question for either 20 marks or 30 marks, and you know so you can do it, you smile. What I want you to do come next week, Friday. The final timetable is out, and I sent it off to you. What I want you to do come next week, Friday, is you're going to attempt the questions that you have most information about first. Any exam at all that you're doing, you read through the question paper and you attempt the question that you have the most information of. So that you end up spending less time. If you do a question that you don't have the information about, you're going to sit down and figure out what I must do here, so what I must do here, so and time is going to run out. Do the question that you have the most information about first and put up those marks. And so once you put up those marks and you know, say, you're right, and you pick up a 30 marks to 30 marks, or your 20 marks to the 20 marks. Let me use the 20. You pick up 20 marks out of 60. All you have to do technically, you know, is make sure you find another question. But like a 10 marker where you know you can do, and you know say you have your 30 marks out of 60, then you can feel relaxed. I know that I've already passed this exam. So you are now in the exam and you are so relaxed that you're going to be looking for the other parts of the question now. Within the 2 questions out of the 4 questions you're supposed to answer, that you're going to do the stuff. So if you know, say a question, say this question on stationary point come for 20 marks. You know, say I have to run for that. There's going to be a 10 marker question for the rest of the question. If you can't do that 10 marker question, you move on to that other question that you know you can pick up at least 10 marks out of. And say you get a, we call it, piecewise function. I see the piecewise function for 10 marks. Run for the question there. And if you can't even do the other parts, just try figure out and you try play around with the other parts to see if you can pick up a little extra 1 mark or extra 2 marks or extra 5 marks here. Because your aim is to go into the exam, you're working smart and not hard. But if you truly prepare yourself for the exam, I'm guaranteeing that you can go in there and answer your full questions. I'm guaranteeing that you can go in there and answer your full questions. I'm depending on you. I'm depending on you to be very successful in the exams coming up. I am being very strategic in what it is that I do so that I can fully prepare you for the stuff. All right? I am moving away from this topic now. The topic is finished. I just seal it off. I just talked to you about it. The ball is in your court. If you don't want to go and prepare for it, I cannot tell you otherwise. Because I'm telling you what to do now, and I'm trusting that you pay me attention and do it. All right. Another question that they can give it in the exam is integration. And I must now turn to integration. Did I give you the rules for integration already? Yes, no?
Yes, sir.
Okay, thank you, Simon. Anybody else remember getting the rules of integration? No,
Yeah, I
yet?
remember, sir.
All right, so let me just see if I can. Um, right, so all right. How do I do this? You share. Let's see if I can do this. There is one other piece. All right, no man. No man, we're gone, Bridget. No, 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 no. All right, there's one other piece that is hiding. A piece of it is hiding. I give you 5 minutes to read through these rules. There are 8 of them. There's a little piece of 8 that is hiding up top right here. So before I move into some examples, read through this for me. I'll give you about 5 minutes to digest it. Then I'm gonna come to you with some questions and answers. All right, 5 minutes starting now. always stay. Thank you. You read through and get some semblance of what is happening. You don't have to fully understand it, but you have some idea as to what is happening. Some of the calculating things.
Sorry, you place rule 3 in green. Is that like the main?
Right. So that is the basis of the rules for integration. All right, and that's where I'm going to start. For differentiation, as you will know by now, you're going to reduce the power by 1. For integration, you're adding 1 to the power and dividing by the new power. You're adding 1 to the power and dividing by the new power. You're adding 1 to the power and dividing by the new power. That's the rule for integration. You're adding 1 to the power and dividing by the new power. All right, so let's go. What this is saying is that the integral of a power function x to the n, x is not equal to -1. X is not equal to -1. X cannot be equal to -1.
You mean n, sir?
N cannot be equal to -1, yeah. Thanks. N cannot be equal to -1. At no way, no point, no time. All right? So now, it's going to be adding 1 to the power x to the n plus 1 divided by the new power n plus 1. See here? Adding 1 to the power n plus 1 divided by the new power n plus 1. And then we have my plus c. My plus c is going to be known as a constant of integration. My plus c is known as my constant of integration. My constant of integration. Because I'm talking about indefinite integrals, I don't know the definite value of it. So I'm just going to put a constant. The constant will take care of it. Remember when you're doing differentiation, when you differentiate a constant, we get 0? Anybody remember that?
Yes, sir.
Yeah. So when we're integrating now, we have to take into consideration that we may have thrown out a constant. So we have to use that plus c to account for that constant that we threw out. Using that plus c to fill that constant that we threw out. We don't know what the constant is. So we're trying to figure out what it is. So we just put that plus c. Once we're given more information about it, we'll be able to find the exact value of the c. Once we're given more information, we should be able to find the exact value of c. All right, let's go. Let's go. So note, we're adding 1 to the power and then divided by the new power. Note, we're adding 1 to the power and then we're dividing by the new power. We're adding 1 to the power and then we're dividing by the new power. Very important. We're adding 1 to the power and we are dividing by the new power. Very, very important. So let us go now to rule number 1. The integral of a constant, sorry. The following rules for indefinite integrals are obtained by reversing the corresponding rule for differentiation. So what it means is that I'm using the opposite of differentiation. So the opposite of differentiation is really integration. Their accuracy is easily checked by taking the derivative of the antiderivative or the integral. So the antiderivative is known as the integral. The antiderivative is known as the integral. So to check it, all we do is just differentiate the integral and to be sure it's equal to the integrand, what it is that we're integrating. All right? So if we integrate a function and we get the answer and then we differentiate the answer, we're supposed to get back the original function, which is the integrand. All right? And then that elongated S is going to be the sign for integration. That elongated S is a sign for integration. This is not an S, it just looks like an elongated S, right? And these are the rules. These are the rules that follow. So the integral of a constant, K, is going to be K dx. And when you integrate the constant, you're going to get X, Kx plus C. Remember, you're adding 1 to the power divided by the new power. Remember, this X is really, sorry, this K is really Kx to the 0, don't? Because anything raised to the power 0 is 1, don't it?
Yes, sir.
Yeah, man. So when I have X to the 0 and I add 1 to it, I can get X to the first. And X to the first divided by 1 is really just X to the first. And X to the first is really X. So I'm going to end up with Kx. Differentiate Kx and what you get.
Okay.
Very good. You get K. Excellent. You get K. So you see, one is the opposite of the other, the opposite of the other, the opposite of the other. And once we're differentiating an indefinite integral, once we're differentiating an indefinite integral, you must have that constant of integration. So I must have my plus C. So if you integrate the function and the integration is correct, and you don't have the plus C, you're going to lose mark. I must have that constant of integration plus C. Once it is a definite integral, sorry, an indefinite integral. If the integral is definite, I will have limits up top and limits at the bottom. I'll have an upper limit and a lower limit. Once I have a definite integral, I'll have an upper limit and a lower limit. That upper limit and lower limit will give me the definite answer, right? But once I don't have that, it is going to, once I don't have no limits at all, it's going to be called an indefinite integral. And how do we treat indefinite integrals? We are going to be integrating. And then at the end of it, we must write plus C. If we don't write the plus C, it simply means that our answer is incomplete. If we don't write the plus C, our answer is incomplete. If we don't write the plus C, our answer is incomplete. So we must have the sign of integration. Now, the second rule says the integral of 1 written simply as dx. Please do not say 1 dx. Don't say 1 dx. If you integrate in 1, we're just going to integrate dx. And when we integrate dx, we're going to get x. And of course, because of indefinite integral, we're going to get x plus c. So remember, we don't say integral of 1 dx. We just write it integral dx. All right? And then jumping now down to 4. Jumping down to 4. The integral of x to the minus 1 or 1 over x is going to be the ln function. We looked at the natural logarithm function ln x. When we differentiate ln x, what do we get? When we differentiate the ln function. Huh?
That's a good question, sir.
Did I do that with you?
Yes, sir, but I like logarithms, sir.
Don't worry about it, man. You're gonna use it a whole lot in calculus too. And I'm suspecting that all of you are going over to calculus too, so we have to get to this. So when I differentiate the ln function, I'm going to get 1 over x. So the ln function, when I differentiate the ln function, I'm going to get 1 over x, right? And 1 over x is the same thing as x to the minus 1. So see here, 1 over x is the same thing as x to the minus 1. So when I differentiate the ln function, sorry, when I differentiate the ln function, I'm going to get 1 over x, which is the same thing as x to the minus 1. And when I integrate x to the minus 1, I'm going to get the ln function. And of course, because it's indefinite, I don't have an upper limit and I don't have a lower limit. It's going to be ln x plus c. Now, x has to be greater than 0. Why, sir? Because you cannot take the logarithm of a negative number. See here, it says the condition x greater than 0 is added because only positive numbers have logarithms. So you can't find the logarithm of a negative number. So oftentimes we use the absolute value of x. And the absolute value sign here is going to be those 2 strokes between the x. So it means that if we have ln negative 3, what we're going to be doing for our answer is to find ln of positive 3. We're taking an absolute value because only positive numbers have logarithms. Only positive numbers have logarithms, all right? And then rule 5 says the integral of a natural exponential function is, we look at the exponential function when we're talking about our differentiation. We looked at the exponential function when we're talking about our differentiation. And when we're differentiating the exponential function, the differential of the exponential function is the exponential function itself. The differential of an exponential function is the exponential function itself. So the differential of e to the x is e to the x. The integral of e to the x is going to be e to the x. The differential, rubbishness, the integral of e to the x is going to be e to the x. However, the integral of e to the kx is going to be e to the kx, because once I integrate the function, I'm going to write by the same function. Once I differentiate, and that is the exponential function. Once I integrate the exponential function, I'm going to write by the exponential function in my answer. Once I differentiate the exponential function will still be in my answer. So if you look at this e to the kx, you recognize that e to the kx is still in the answer here. But what we're doing, we're differentiating kx. And when we differentiate kx, we're going to get k. We just reciprocate it. We reciprocate it and then multiply it by the exponential function. So that's the difference. That's the difference. So the differential of the exponential function, what we did was to write by the exponential function itself and then differentiate the function up top and then multiply it by the exponential function. When we're integrating, we're going to write back the same exponential function. We're going to differentiate the same power, but instead of multiplying by the differential, we're going to multiply by the reciprocal of the differential. We're going to multiply by the reciprocal of the differential. I'm going to move to some examples. You'll see it even better. And then rule 6 says the integral of a constant times a function equals to the constant times the antiderivative of the function. What it is saying is, if I'm integrating a constant, the integral of k f of x, because the k is a constant, I can draw it out of the integral. I can put it out here so I can just make the function, the constant, stay by itself and then integrate the function. And when I get my answer, I just multiply that by the constant. That's all that it is saying. Let me jump to number 8, because number 8 is something similar. If I'm integrating a negative function, all I have to do is to draw the negative function out of door. See it right here, so integrate the function. When I finish integrate the function, all I do, I just multiply everything back by the negative one or the negative number, right? And then the last one says the integral of the sum of difference of 2 or more functions equals to the sum of difference of their integrals. So I don't understand what that is saying. Not a problem. What this is saying is that if I'm integrating a function plus another function, it's the same thing as us integrating this function by itself and then add it to the integral of this other function by itself. So you see, I am, instead of doing the integral of this function plus this function d of x, I do the integral of this function d of x plus the integral of that function d of x. Or I do the integral of this function d of x minus the integral of that function. So if I'm doing the addition or the subtraction of a function, I can go ahead and integrate everything as a whole, or if I want, I can integrate them individually. That's all that this is saying. All right? So let me use the last 15 minutes of the class to just work through some questions with you. So when we're integrating this indefinite function, the integral of 1 over x squared, one of the things that I can do, I can, and when you're doing the integration here, for this level, I want you to do as many conversion as you possibly can. Convert it as often as you can, as many times as you can, so that the function becomes easier for you to integrate. That's the best way I can teach this at this point. Time is against us, and I want to be able to cover this stuff so that you can be in a position, to understand, of course, what I'm doing, so that you can go and reproduce it in the exam and pass the course. All right? Work with me now. So I'm going to rearrange. So I'm going to put this as x to the negative 2. Remember that you're adding 1 to the power, and then you're going to divide by the new power, right? Everybody see, oh, I get x to the negative 2. If this is x to the positive 2 here in the denominator, when I reciprocate it, I'm going to get x to the negative 2. But remember, you're adding 1 to the power and dividing by the new power. So when I add 1 to negative 2, see here, x negative 2 plus 1, you remember I'm dividing by the new power. So the division here is going to be negative 2 plus 1. The rule says you add 1 to the power and then you divide by the new power every single time you're doing integration. You're adding 1 to the power and you're dividing by the new power. Every time you're adding 1 to the power, dividing by the new power. It's an indefinite integral, so I must have my plus c. It is an indefinite integral. I must have my plus c. All right? Only the definite integrals don't have a plus c. Sir, what are the definite integrals again? When you have an upper limit and a lower limit. Sir, I don't see any of those yet. Yeah, I don't reach here, say yet. I don't reach here, say yet. Now, so I'm adding 1 to the power. Negative 2 plus 1 is going to be negative 1. See here? I have x to the negative 1. And whatever power that is going to be up here is going to be the same power down here, because since it's the same power we're talking about in any event. And then we have my plus c. And then now this is going to become negative x. I'm simplifying. Remember, c is a constant. I'm simplifying. So I'm going to have x to the negative 1, negative x to the negative 1 plus c. So we never normally write, as I told you before, we never normally write our answer as a negative index. We always try to write it as being positive. That's just a general rule of thumb. We never normally write our answer as a negative index. We write it as something that is positive. So I'm going to convert this x to the negative 1 as 1 over x. As 1 over x. And this here will be my answer. Look at that for a minute. If there are any questions, I'm right here. Ask me your questions. And then I'll be more than happy to move to example 2 with you. And incidentally, these questions are not long. They look this long because I'm explaining what is happening to you with the first 3 or so questions. By the time I move to question 4 or question 5, my answers will be done in either 2 lines or 3 lines. Look at it. Let me know. I can move on to the second example. Talk to me, and I don't want to sit down here and wait until 7 o'clock come and we don't even go through example 3. We have 10 minutes, 12 minutes. We can do example 3 at least.
All right, finished.
All right, good. For the rest of your stay, Simon. Who else is here? Mario.
Finish
So we
right
can
now.
move.
All right, good job. All right. So now, let us look at example 2. Example 2 says, integrate. Remember, this elongated s means to integrate. Integrate 3x cubed minus 2x to the 4th plus 7x minus 2 dx. Remember, I said to you that from the law, one of the laws, the f of x plus or minus g of x, I can just go ahead and just integrate f of x dx plus the integral of f of x dx plus the integral of g of x dx. I can integrate them individually. All right. That's what we're going to do. That's what we're going to do. Watch me. So I'm integrating 3x cubed d of x. See, the first one, boom, plus the integral of negative 2x to the fourth dx plus the integral of 7x dx plus the integral of negative 2 dx. That was rule 7 that we looked at earlier. That was rule number 7 right here. So that was rule 7 right here. So follow me?
Yes, sir.
All right. And then now, where are we? And then now, I can fix it up because rule number 8, see it up at top here, so rule number 8 says if I have a negative sign, we just draw out the negative sign and just integrate the function, and then when we finish everything, we just multiply it by the negative sign. True or false?
Sir.
Good. I want you to answer me so I know that you're still with me. Good. So you see what I did? I just write back this 3x cubed dx right here, so this negative sign, I can haul it outside. So this sign can change now from positive to negative. So I will just end up integrating a positive 2x to the fourth. I write back the 7x, but guess what? I have yet another number here. I have yet another number. Negative 2 dx. I can draw the negative sign. I can draw the negative sign. And then I come over here, so now, and I say, but hold on. This 3 is a constant. You remember the rule, one of the rules said that when a constant is there, I can just draw it out and just integrate the function, and then I multiply everything. See here? I draw the constant, then I'm going to integrate x cubed d of x. When I get the answer, I just multiply it back by the 3. Similarly, this 2, I can draw him out. When I draw him out, I'm going to have negative 2 out the door right here, so. And just simply integrate the x to the 4. I can draw out the 7 right here, so. And you see this 2 right here, so I don't know why I'm going to leave it over here, so no. Because that 2 can draw out. See, that was rule number 2. That was rule number 2, right? Now recall, we add 1 to the power and then divide by the new power. Always remember that. We're adding 1 to the power and then we're dividing by the new power. So now it is that it is in its simplified form. We can go ahead and integrate. You remember that 3 here? I'll go use so multiply everything. So we write back the 3. Boom. We add 1 to the power divided by the new power. X to the third becomes x to the fourth divided by 4, don't?
Yes, sir.
Teacher, x to the fourth divided by 4. Minus 2. So the 2 here, we put back the 2. Then we're integrating x to the fourth. It's going to be x to the fifth over 5. See it right here, so? Then we draw back the 7. Boom. And then we're integrating x. Remember, x in and of itself is really raised to x to the first power. So since I have an imaginary 1 up there, so it's going to be 1 plus 1 is 2. So it's going to be x squared over 2. See it right here, so x squared over 2. And then this is going to be the integral of dx. When I integrate dx, what do I get? When I integrate dx, what do I get? when I
X
when I
plus C.
very good. When I integrate dx, right here, so rule number 2, when I integrate dx, I'm going to get x plus c. When I integrate dx, I'm going to get x plus c. All right? So what is going to happen here now is that x plus c, I'm going to I never did something right here, say no. But I did it in question 3, so I'm not going to talk to you about it. And I'm not going to talk to you about it until I reach question C. Question 3. So I'm going to put my plus C. Remember, it's an indefinite integral. I must have my constant of integration. Cannot have my constant of integration. I must have my constant of integration. All right? We're going to fix it up. All we're going to do is multiply this, as I told you. We're just going to multiply it out. So we're going to say 3 times x to the 4th is 3x to the 4th over 4. Negative 2 times x to the 5 over 5 is negative 2x to the 5 over 5. This 7 we're going to multiply by the x squared divided by 2. See, Tressa? And we already multiplied this negative 2x, and then we put the plus c. Boom. That is our answer. I am going to give you 1 minute to look over that. And then I'm going to go through question 3. I spell out something in greater detail in question 3 that I never spell out in question 2. And I want to do that before we leave class tonight. So I have 5 minutes. I'm going to give you 1 minute out of the 5 minutes. And then I will come back to you. 1 minute. I'm right here, not even muting. I'm right here. Look at it. When you finish looking at it, let me know so I can move on.
Sir, when we are working out, we have to write back what you have in black, the rules, or can just jump into the calculation.
Jump right into the calculation. Now, only because me I introduce a topic, where I see me I show up and I talk about rule this and rule 8 and rule 2 and rule 3 and them something there. No man, you must just know the rules and then we're good to go. Very good question though. But no, you don't need to just know the rules and do what you need to do. You get that, everybody?
Yes, sir.
Yeah, man. All right. Let me jump. I have 4 minutes. Let me jump into example 3. I want to be able to do example 3 with you. Let me jump into example 3. It says, integrate all of this dx. It's the same thing. It's the same thing like I did before. So I'm going to say, I'm integrating 4x to the 5th. I'm integrating 4x to the 5th. So when I integrate 4x, it's going to be 4x to the 5th dx plus 7x cubed dx minus, plus the integral of negative 6x squared dx plus the integral of x dx plus the integral of negative 9 dx. Then all I'm going to do is the same thing like I did before. Take out the constant and put the x squared, x to the 5th dx. Take out the constant, put the x cubed dx. Remove the negative 6x as a constant. No. And I'm just going to integrate the x squared. I'm going to, this one can remain as is because there's nothing to remove. Then I just remove the negative 9 and have it right that. But I didn't want to the power divided by the new power. This is what I never did for the first one, for question 2. For example 2, I never did this one, but I want to show you this point here now. When I integrating this first piece, this first piece here is an indefinite integral. So I must have my plus c when I finish. So this is going to be 4x to the 6 over 6 because I add 1 to the power divided by the new power. So we have 4x to the 6 over 6. See here? 4x to the 6 over 6. But I must have a plus c because I'm integrating this piece here, which is an indefinite integral. So we have a plus c right here. So, all right, to put it down. Then I want here now we're going to integrate. I add 1 to the power divided by the new power. So this is 7x to the 4th over 4. See here? 7x to the 4th over 4 plus my c. The one here is going to be negative 6x to the 3rd over 3. See here? Negative 6x to the 3rd over 3. And I'm going to put my plus c. The one here is simply going to just be x squared over 2 plus c. X squared over 2 plus c. So, you get them something there. All I'm doing is adding 1 to the power divided by the new power. This negative 9, the integral of x is going to be negative 9x. And that also is going to be plus c. All right? Now, you see that little c here? Plus a little c here? Plus another little c? Plus the one here? And the one here? Are just going to give me c. A constant plus a constant is equal to a constant. Tell me if you get that. 3 plus 2 is what?
5.
Is 5 a constant?
Yes, sir.
Yeah, man. So a constant plus a constant is a constant. So that's why in example number 2, I could have just write 1c. Because a constant is a constant is a constant. But I spell it out right here, so because I want to show you that when I do the individual terms, I'm going to get a little piece of c, and a little piece of c, and another little piece of c. When I add up all of them c, then I just get a bigger c. But a constant is a constant. 1 plus 2 is 3. 3 is a constant. 3 plus 1 is 4. 4 is a constant. 4 plus 6 is 10. 10 is a constant. So a constant is a constant is a constant is a constant. I'm going to end here, but just to say to you, remember that when you are integrating, you add 1 to the power and you divide by the new power. All right?
All right, sir.
All right, all the best. I hope you learned something tonight. All the best.
You too, sir.
Cool.
All
Take
the
care.
best.
Bye-bye. Come on, pick up yourself.